In this video, I will be going over 2.5 postulates and proofs. So the goal here is that you will define a postulate and explore some fundamental postulates of geometry. A postulate or axiom is a statement that is accepted as true without proof. And a deductive argument, as we already have studied a little bit, is a logical chain of statements that link the given to what you are trying to prove. So basic ideas about points, lines, and planes can be stated as postulates. So remember, postulates are things that are accepted as true without proof. And so looking at the list below, you can see a few of the postulates here that we have. We have postulate 2.1 through 2.7, and you'll be referencing these throughout the rest of these notes and then on your assignment as well. And so the first postulate is that through any 2 points, there's exactly one line, and you have an example there. Through any 3 non-collinear points, there's exactly one plane. And then 2.3 is a line contains at least 2 points. 2.4 is a plane contains at least 3 non-collinear points. And 2.5 is if 2 points lie in a plane, then the entire line containing those points lies in that same plane. Then we also have postulates for intersections of lines and planes. 2.6 states if 2 lines intersect, then their intersection is exactly 1 point. 2.7 states if 2 planes intersect, then their intersection is 1 line. Now down at the bottom here, we have example 1 that says determine whether each statement is always, sometimes, or never true. And you're going to use these postulates here to help decipher your answer. So there is exactly 1 point that contains points A, B, and C. Now looking at that example, number 1, the correct answer would be sometimes, because if A and B are collinear, they are contained in many planes. So if they are collinear, it could be in different planes because they're on the same line. However, if they're non-collinear, then they are contained in only 1 plane, so they would have to be just within that plane. Example 2 says points E and F are contained in exactly 1 line. So would that be always, sometimes, or never true? And so points E and F are contained in exactly 1 line is always true, because referencing postulate 2.1, through any 2 points, there is exactly 1 line. Example 3 states 2 lines intersect in 2 points, M and N. So would that be always, sometimes, or never true? And the correct answer would be never, because the intersection of 2 lines is 1 point. So you can't have 2 lines intersecting at 2 points. They can only intersect at 1 point. On the second page of notes, we'll be looking at proofs. So a proof is a logical argument in which each statement is supported by a statement that is accepted as true. Paragraph proof, or an informal proof, is written in paragraph to explain why a conjuncture for a given situation is true. So although we may call it an informal proof, it doesn't mean that it's not true. It just means that it's not in regular proof form. It's written in paragraph form. And so a theorem is then a statement, a conjuncture that has been proven. So we know that it's true. Now we do have the process of proofing. And so the proof process consists of, first, you give the hypothesis, then you have statements and reasons, and then you prove it with your conclusion that is drawn. And so step 1 is list the given information, draw a picture if possible. Step 2 is state the theorem or conjecture to be proven. Step 3 is create a deductive argument by forming a logical chain of statements, linking the given to what you are trying to prove. Step 4 is to justify each statement with a reason. And so the reasons could be definitions, algebraic properties, postulates, and theorems. And then step 5 is to state what it is that you have proven. So here, down below, I have an example. So this example states, given that M is a midpoint of XY, line segment XY, Write a paragraph proof to show that XM is congruent to MY. So you don't know what the image is. So what we did first was we went ahead and we wrote what we know, and then we drew a picture and what we want to prove. So given that M is a midpoint of XY here, prove that XM is congruent to MY. So here we have XM is congruent to XY. So if M is a midpoint of XY, then from the definition of midpoints of segments, we know that XM and MY, meaning the left and the right side, are equal to each other. This means that XM and MY have the same measures. So the lengths are the same, their measures are the same. By the definition of congruence, if two segments have the same measure, then they are congruent. So thus, XM is congruent to MY. So you can see here we have steps 1 and 2, 3 and 4, and then 5. So following that same process from the table above, here, steps 1 through 5, and you can see here we have an example. We'll start with the hypothesis, given the statement of reasons, and then prove with the conclusion. We have example 1. In triangle ABC, BD is an angle bisector. Write a paragraph proof to show that angle ABD is congruent to angle CBD. So here is your triangle right here. And so by definition, an angle bisector divides an angle into two congruent angles. So you can see here that these are BD is your angle bisector, and that means that each angle is congruent. So since the line segment BD is the angle bisector, that means that angle ABC is divided into two congruent angles, which means ABD is congruent to angle CBD. Now, just to provide you with two more examples here, we have given that angle A is congruent to angle D, and angle D and angle is congruent to angle E. Write a paragraph proof to show that angle A is congruent to angle E. And so this is just in reference, just in general. It is not in reference to this triangle here. It's its own question. So since angle A is congruent to angle D, and angle D is congruent to angle E, then the measure of angle A and the measure of angle D are equal to each other, and the measure of angle D is equal to the measure of angle E. So this just says if these two are equal to each other and these two are equal to each other, then their measures are equal to each other, and these measures are equal to each other. So by definition of congruence, that means that angle A is equal to the measure of angle E. So here, this means that if this is equal to D and D is equal to E, well then A has to equal to E. That's what this is saying here. That's called the transitive property. And angle A is congruent to angle E by definition of congruence. So that would be your example for if you're referencing angles, congruent angles. So you can see there it's written in paragraph form. We followed the 5-step process as well. So example 3, it is given that line BC is congruent to EF, to line EF. M is a midpoint of BC, and N is a midpoint of EF. Write a paragraph proof that shows that BM is equal to EN. So what this is saying is that these two lines are congruent. M is the midpoint of this one, and N is the midpoint of this one. You're trying to prove that the BM, this first half, is the same as this one, EN. So here, M is a midpoint of BC, and N is a midpoint of EF. Again, we're just writing what is given. So that implies that BM is half of BC, and EN is half of EF. Okay, so that's just saying that this part is half of the total, this part is half of the total. Line BC is congruent to EF, so what that means is that BC is equal to EF. The length of them are equal. By definition of congruence, half of BC is equal to half of EF. By the multiplication property. Thus, BM is equal to EN by the transitive property. So we can see here that we have paragraph proofs. In order to help prove that something is true, you'll use what you know, use what's given, and then use your math knowledge to come up with a proof for each. So these proofs, just like conclusions or conjectures, they can be written in different ways. So however you come up with a proof, it may not be written exactly like this, but you do have a little structural format there with steps 1 through 5, and you want to be sure that you use what you know to draw a conclusion. You don't want to ever assume something. Something has to be either a postulate or a theorem, a property, for you to reference when proving.